Okay, so what we want to talk about are the characteristics of the graphs, and we've already talked about that a little bit, but we're just going to formalize it, okay? So we're going to do, and we're only going to look at cosine and sine for now. So characteristics, try to spell it right, of sinusoidal functions. And as we talked about yesterday, sinusoidal just means either y equals sine x or y equals cos x. Okay, the ones that graph like a wave. So when they graph like a wave, we give the different things different names. So we are going to talk about the fact that they're periodic. And the fact that they're periodic means that they repeat. So they repeat, and we get that repeating pattern. And how often does the pattern repeat for a basic y equals sine x or y equals cos x? Every 2 pi. So we call that the period. And those of you that have done any physics at all, you know what a period is. The period is the time for one cycle. For us, it's not a time. It's a length for one cycle, but we're still calling it period. Okay? So the period is the distance for one cycle. The domain, what's the domain for sine x and cos x? All real numbers. The range is the same for all of them. And the range is between -1 and 1. Give myself a little more space here. Now the y-intercepts are different, but you need to remember them. So if we have a sine x graph, where's the y-intercept? At y equals 0. And for the cosine graph, you can look at your graphs from yesterday. The y-intercept is at y equals 1. Okay, and again, they're different x-intercepts for sine x and cos x, and we just developed those a moment ago. So x equals n pi for sine x, or x equals 2n plus 1 pi for cos x, where n is an integer. So all multiples of pi and all odd multiples of pi here. Sorry, all odd multiples of pi by 2 we want there. Now, something else that I want to point out to you. What do we notice about the relationship between cosine x and sine x? So if we are looking at the graphs of the two and comparing them, so if I slide sine x left pi by 2, I will get cosine x. And so they are related to each other in that way, in that they're a translation one to the other. Same size, same shape, just different location on the graph. Okay, a pi by 2 translation to the left. And then the last thing, which you noticed with your, when you were graphing with different values in front, if you have y equals a sine x, or y equals a cos x, a is at vertical expansion or compression, but in a sine graph, what we call that is an amplitude. And when I write amplitude, I write it in absolute value because amplitude for a wave is never negative. All the amplitude is telling you how high is the crest or how low is the trough. It's a value without sign. It's a scalar value. Okay? So those 7 things about sine and cosine functions that you have to keep in mind. Are you all right?
Yeah.
Okay. Now, so you're looking at this sheet. Okay. And on the first page here, there's a lot of writing on this sheet, so I just want to walk you through a little bit of it. Okay. So it's starting at theta equals 0. And so it's telling you that y equals 0, x is the radius. So y over r, which is sine, is 0, and x over r, which is cosine, is 1, and so on. And so then we're going to pi over 2, pi, 3 pi by 2, 2 pi, and so on. So they're generating this table down here by just rotating it around the circle for these different values and calculating sine and cosine for these different values. Okay? And then the table is allowing them to graph y equals sine x and y equals cos x. So sine x is the bold and cos x is the dotted, which is exactly the activity that you did yesterday, but you did a few more points in there. Okay? Everyone all right with that piece? Then there's some notes at the bottom. Each function cycles through the values 0, 1, 0, negative 1, and of course all the values in between, and advances every pi by 2 radians, as x advances every pi by 2 radians. These are called periodic functions, okay? And it gives you the domain and the range and the x-intercept and the the y-intercept for both of them, and it's talking about the horizontal translation, and then there's going to talk about special angles in a moment. Okay? But that is everything we've just discussed, basically, on one nice sheet. Okay? So before we get to the next page of the sheet, let's talk about vertical displacements of these graphs. So what I want you to do with your graphing calculator right now is I want you to graph y equals sine x plus 2, and y equals sine x minus 1, and then see what happens. So when we graph sine x plus 2, what does it do?
Goes up 2.
Goes up 2. And when we graph sine x minus 1, what happens? Down 1. Okay? Now that's exactly what we would expect. The only difference is we call it vertical displacement. Every point on the graph gets displaced vertically, either up or down. And we use that term because it's a wave. So we're talking about the displacement of the particles in the wave. Okay? All right, so we've already dealt with amplitude. Whenever we change the value in front of the cosine or the sine, we're going to change the amplitude. So this is an amplitude. What will the amplitude be here for this one? Any ideas? Echo, what do you think the amplitude is here? Amplitude is 2. Right. I'm going to just move this out of the way for a minute. Okay, what's the amplitude for y equals cos x? What's the normal amplitude? 1. What about this one? Amplitude is a half. What's the amplitude here? Also 1, yes. We ignore the negative sign. The negative does transform the graph as we would expect. It reflects it over the x-axis, but it doesn't change the amplitude. And amplitude is always positive. We never report the negative with an amplitude change. Okay? All right, so if you look on the second sheet, the second page of your handout. Okay? And this handout is also available on the website down below where it has files that have been added. So when we measure amplitude, we're measuring the height from the center line to the peak of the wave, or from the center line to the bottom of the wave. So we call this the midline or the center line. Okay? And it's not necessarily an axis, as you saw with those vertical displacements. It is the line that cuts through the middle of the wave. Okay? And it's a horizontal line. So as the wave moves up and down, that line moves up and down as well. Okay? Amplitude is always the value in front of the function, but if we know the maximum value and the minimum value of the wave, we can find the amplitude by simply subtracting and dividing by 2. So essentially we're finding the middle value between the maximum and the minimum. That's going to be your amplitude. And we don't worry about if it's negative. Okay? Well, its maximum should be bigger than minimum, so we subtract and we get 2. Okay? Or the amplitude is the absolute value. It's hard to see. I can see it when I highlight, but you can't. Is the absolute value of the letter in front of the function. Okay? And so down here we have some different amplitudes, just like we saw when we were graphing them. So for the solid line, what's the amplitude for the solid line? Amplitude is 1. For the 0.5 graph, the amplitude is what? Half. And for this one, the amplitude is 2. And here the amplitude is 4. Okay, and you can see that an amplitude of 4. Notice nothing else has changed. The x-intercepts are all the same. The period is all the same. The only thing that changes is how high are the crests and how low are the troughs. Yes, Jonathan?
This always the number before sine, like the number that...
Yeah, it is, the number in front. But if I haven't given you an equation, then you would look at that maximum value, subtract the minimum value, and divide the 2 by 2. Okay? So if you don't have the equation, then that's another way to find it from the graph. Okay. How are we doing for time? We're doing okay. Period. If we vary the period, essentially what we're going to do is take these graphs and either compress them or expand them horizontally. Okay? Because we're going to make them repeat more often or less often in a 2 pi distance. Okay? So when we do that, that means that we're putting a number here in front of the x, because that's a horizontal expansion or compression by putting a b value in front of the x. Okay? Questions about that? So if you read this, I'll let you read this little bit at the bottom of this page about period, and then we'll talk about it. Okay, so just as you would expect, if there's a b in front of the x here, we've got a horizontal expansion or compression by a factor of 1 over b. So just like we were doing before when we were transforming any functions. So 1 over b is now what we're going to multiply the period by. So if the original period was 2 pi, the new period is going to be 2 pi divided by b. And again, it's the absolute value of b, because period is never positive or negative. It's a scalar measurement. It's a measure of distance. It's not a measure of displacement. Okay? So it's 2 pi divided by b, whatever that b value is. That's how the period is going to change. Now, if you look on the next page, they have various graphs, which you can also put into your calculator if you want to. But we have cos x is the solid line here with a period of 2 pi. Cos 2x is the dotted line. So this one here, notice that it is now, it's expanded or compressed, the dotted line. So not the dashed line, but the dotted line compared to the solid line. Is it expanded or compressed? Compressed. It's compressed, okay? And it is compressed by a half. That's what the 2 does, compresses by a half. So if the original period was 2 pi, the new period is a half of 2 pi, which is pi. So if you look at the dotted line here, It repeats now from a maximum back up to a maximum in pi. One repetition is pi now. Okay, one period. Does that make sense? So for this one here, the dashed line, it's now expanded. You can see that it's quite a bit wider overall. It's expanded by a factor of 2. So 2 times the original period, 2 times 2 pi is 4 pi. It now has a period of 4 pi. So if we go from a maximum here to a maximum again, that's one repetition and that's 4 pi. Okay? Questions about that? Keeping my eye on the time. Okay. Okay. Here you see we're combining period and amplitude. When we combine them, that one's a vertical transformation and one is a horizontal transformation. So we get a horizontal compression here, and then we also have a vertical compression. And that's what this dotted line is showing compared to the solid line. Okay? We're going to talk about phase shift really quickly in this class, and then tomorrow we can practice all of these things. We also have to deal with tan tomorrow, so we'll save tan for tomorrow. But phase shift is essentially just what we get when we shift left or right. So a slide left or right is now called a phase shift because it's a period, or because it's a periodic function, a wave, and so we talk about shifting the phase of the wave. How many people have heard the term phase when it comes to waves before? In phase or out of phase? So that's where it comes from, okay? Because we're dealing with waves. So we're shifting it. Here we're shifting it to the right, 2 pi by 3, and here we're shifting it to the left, pi by 3, okay? These are period changes, all right? So now when you look at it, what's the period of this one? Remember that period is 2 pi divided by b. So what's the new period going to be? 2 pi divided by 4, which is pi by 2. What's this period going to be? 2 pi divided by a half, which is 4 pi. Okay? So in general, that's what we have. In general, I am still recording, right? Good. We have A, B, C, and D as our same transformations as we had before, but we just have different names for them. A, we used to call it vertical expansions and compressions. Now it's our amplitude. And our amplitude can be calculated as the absolute value of A, or the difference between the max and the min divided by 2. B used to be our horizontal expansion or compression. Now it's telling us what our period is. Our period is 2 pi over B. C used to be our left and right slides. Now it's our phase shift left and right. And D used to be our up and down slides, and now it's our vertical displacement up or down. Okay? We are going to be graphing these tomorrow, like putting it all together. When we do, the order for periodic functions is not as set in stone as it is for other functions. Because they're periodic, you can really do it in any order. We're going to do the vertical displacement and the amplitude first. Notice that this is a displacement, but we can still do it first, because that's going to set up the frame for us for graphing, and then we're going to do the phase shift and the period